In part A, they give us some information, and very important thing is VAB equal to VDC. So this angle is 110 degree, while this angle is also 110 degree. To get the angle VBA, we just need to focus on the plane. Triangle VAB here. We just focus on this plane because this is the triangle included angle we need. So we have 110 degree, we have 18, we have 30 here. What is asked is about the angle VBA. So we are talking about this angle. We just let it be theta. It's just easier to read in equations. Maybe you may just keep the format angle VBA is totally fine. So we have two angles together with two sides here. So we should use sine formula instead of cosine formula. So we are going to label a pair of angle and line. For this angle, we have the opposite line. For this line, we should able to find out this angle. So I find out this angle fine first. After I find this angle out, then I can find the final angle by angle sum of triangle. So I use the sine formula now. Sine phi over 18 should equal to sine 110 degree divided by 30. So to get phi, we isolate all the things to another side, and then phi is equal to shift sine this item. We get 34.32008291 degree. Therefore, our target VBA, that means theta, is equal to 180 degree minus 110 degree minus 34.32. Then we get 35.67991709 degree. You may write 35.7 degree correct to three significant figure. That's all for part A, and then in part B they say that there's some midpoint of certain line. So here is 9, and then this is 15, while this is 15, and by the midpoint theorem, if we cut it by using the midpoint, then this length is 10, then this length will be 5. So BC is 10 here, representing MN is 5. Or if you don't know what is about midpoint theorem, at least you know that it's similar triangle with the ratio 1 to 2, the length ratio 1 to 2. So that's why this is just half. And what is asked about this diagram is they say the area of trapezium PQNM is less than this amount. We have to distinguish is this claim correct or not. So our interest is the cross-section area here, this trapezium. We want to know the area of this trapezium, MNQP. We already know that MN is 5, and then we also know that PQ is 10. Now the problem is, what is the vertical height? If we get the vertical height, then we can solve the whole question. And in order to find the height here, we are also interested in MP, because by the midpoint theorem, if you know this is VA, then this will be half of VA. That's what we are going to do. If we can get this one, how long is it? Then it may be possible for us to solve what is H here. Therefore, to know more, we find out what is VA first. Again, VA is the same plane that we mentioned in part A. We already know 1830 110 degree. We also know that what is this angle. So basically, you may use the answer in part A. 35.679911709. You may use the answer in part A to find out how long is VA, or you may use cosine formula to find out what is VA. But cosine formula involving solving quadratic equations, so basically the calculation is a little bit more complicated. I try to use sine formula here. So I let VA be x, and then I try to solve it. We have a pair of angle and line, and also we have another pair of angle and line. So we can start write it. X divided by sine the opposite angle 35.67991709 is equal to 30 divided by sine 110 degree. So therefore x is 30 times sine then we get 18.62065904. Our target is to find out MP to know more about this trapezium. So we know that MP is equal to 1 over 2 times of x is equal to 9.310329519. And then now, how can we get the height here? It's a very typical tricks for a trapezium. We can draw a rectangle between, and then we just connect these two triangles. Then it will form an isosceles triangle. Now the width here is 10 reduce 5, so this is 5. And then we have 9.31 something, so therefore we can get the vertical height here. Or even simpler, we don't connect them, but we just consider one single right angle triangle here. So we just consider MP and also the perpendicular foot here. We have MP is 9.31 something, and we can also find out the width here, which is 10 minus 5 and then equal distributed to two lengths, so it is 5 divided by 2. And also we have another isosceles triangle which are the same, but we just use one of them is good enough. So we just focus in here. What we need is the height. We have the hypotenuse, we have the adjacent side, so we can use Pythagoras Theorem to find out h. Therefore, the height of trapezium is equal to square root 9.310329519 square minus 5 over 2 square. Then we get 8.968. So we finished the most difficult task already. It's time to calculate the area of this trapezium. And don't forget to tell the examiner you know that Mn is equal to half of PQ. So Mn is equal to 1 over 2 times of PQ, which means it's equal to 5. Therefore, we can continue to get the area of trapezium is equal to 1 over 2 upper base, which is 5, plus lower base 10, and then times height. We get 67.263 something something cm square. And then compare with the reference here, it is smaller than that, so smaller than 70 cm square. And then it's less than. Do you agree? I agree. It is smaller than. So we agree the claim. In order to solve this kind of question, the key point is you must set up the strategy first to find out how can you get the answer to consider about the cross section and the plane one by one. Don't merge everything together. Our human brain is good to handle 2D problem, but not 3D. That's why you have to downgrade it to 2D diagram. And even though you have no method to solve it, just try to write down as much as the information that you think it is correct. Maybe you get some method mark because of that.